Thank you for the introduction. I'm here to talk to you a little bit about my research using diamonds to detect X-ray beams. And this might sound a little crazy, but perhaps it is a bit crazy. So I work at something called a synchrotron. Now, if you don't know what a synchrotron is, that's okay. It's basically a great big X-ray microscope. We produce beams of X-rays that are literally 1 billion times more intense than a hospital X-ray. We focus them down to a micron or so in size. Now, I don't have any, but those of you with hair, that's 10 times smaller than a human hair. We use this machine to image all sorts of things. Bacteria and viruses can be brought to us, and we can look at their atomic structure in order to make better vaccines. People have brought us fossilized dinosaur eggs, and we can look at what's inside them. But when you've got these incredibly tiny X-ray beams, you want to make sure they're not moving over time, and I use diamond to make sure I do that. To explain why this is, I'm going to show you an image, and I want you to think about this circuit diagram. What happens? Well, if you've got really, really good quality diamond, actually nothing happens. Diamond's a fantastic electrical insulator. And I'm going to try and explain to you why that is by dressing up as a carbon atom. I don't know if you are aware that a man was going to dress as a carbon atom, but I'm afraid you're trapped with me now, and the doors are locked. So carbon, it's got 6 electrons. And you might remember from high school that electrons live in electron shells. So the first 2 electrons, well, they live in the innermost shell. And as a result, they get clipped here. The remaining 4 electrons in diamond do something interesting. They spread themselves out nice and wide, like this, and they spread themselves right out, and they grab hold of the neighboring carbon atoms. And so then they grab on tightly, and this is why diamond is so strong. All of the electrons are grabbing hold of the neighboring atom, but as you can see, there's no spare electrons to conduct any electricity. But it's okay, because you might remember a high school experiment. You shine UV light at a metal, and you get electrons liberated from the surface. Well, diamond does the same thing. When I shine X-rays at diamonds, these electrons here, well, they get kicked out of the atom, and then are free to flow through the material. Now it starts conducting. So I can use this as an X-ray detector. So I use man-made windows of diamonds. They're not very big, and they're not shiny. You can't put them on a ring. Well, you could if you wanted, but my girlfriend wouldn't be impressed. And I paint little metal pixels on the surface of these, and the electrons that are liberated flow to one of those metal pixels. By measuring which pixel, just like on a digital camera, by measuring which pixel sees those electrons, I can measure where the X-ray beam is. I can always make sure I steer it back to the right place and make sure the X-ray beam is stable. And in this way, I can take the best possible X-ray photographs of whatever it is that I'm trying to measure. So that's a summary of my research, and I'll ask if you guys have any questions now.
Thank you, Chris. Thank you very much.